Welcome to the final round of Calculus and Jeopardy! I'm your host, Penelope, and this is my co-host, Sylvia. After many competitive semi-final rounds over the past few weeks, we have narrowed the competition down to our final two contestants, Megan and November.
A quick refresher for our viewers who haven't been tuning in all season. Calculus and Jeopardy is a fast-paced game where contestants answer calculus questions and battle for the most points. Some questions require a calculator, others don't. Once a player solves the problem, they hit the buzzer.
That was easy.
And we, the hosts, review the answer. First one to solve the problem correctly gets the points.
Here's the categories for tonight's game. First, we have optimization. These word problems will require a calculator. Next, we will have derivatives category. Easier problems may simply ask contestants to take the derivative of a function, and more complicated ones will ask contestants to apply the derivative to say, find the slope at a point. Next, we have limits. These will be without calculator as well. Finally, we have the integral category. Many different types of problems to choose from this category.
To begin, let's meet our contestants. This is November. She's one of our older contestants, already 18 years old, and while she might not look like it, she's been one of our toughest competitors this season. So November, besides sweeping every round that you've played on Calculus and Jeopardy this season, we hear one of your other challenges is typing at a speed of 300 words per minute. Is that true?
I've never been on the phone in my life.
Okay, moving on. Megan. You're only 15 years old and you'll enroll in Stanford next year. Truly one of the greatest mathematical minds of our generation. Is it true that you can speak 5 languages?
Actually, I can speak 7 now. I just learned Portuguese and Farsi this weekend. You'd be amazed at the amount of similarities Portuguese has to some of the earlier...
Okay, let's start the game. Since you have the most points, Megan, we'll start with you. Which category would you like?
Can I get optimization for 300?
Absolutely.
Optimization for 300. Good choice! Has 150 feet of fencing to make 4 cow pens along a river. No fencing needed along the river. What dimensions gives the pens the maximum area?
That was easy.
November, what's your answer?
It's the drowning cows that the farmer will have because he didn't put fencing along the river.
Oh dear, no.
That was easy.
Megan, do you want to show us how it's done?
Absolutely. First, I drew a picture.
At least I got that part right.
150 feet the farmer had was the perimeter, which would equal 150 equals 5x plus y because of the picture I drew here. And then the area is obviously x times y. So in order to find the maximum, I would have to find the derivative of the area. But first, what I had to do was turn y into x or x into y. So I turned y into x so that my area was equal to 150x minus 5x squared. So I took the derivative of that, which is 150 minus 10x, and factored that out. So 0 would equal 10 times 15 minus x. And then plugging that into the equation and several other numbers before and after, I could see that we have a maximum at 15, which would give us the maximum number of x that would make the area the biggest. So then I plug that into the original equation for perimeter, and then we can see that y is equal to 75, so the dimensions are 75 times 15.
Sorry, Megan, but your answer is incorrect. Your calculations are on point, but you forgot the units. The correct answer is 15 feet by 75 feet.
What? But the units don't matter. It's all about the numbers.
Ha! At least I didn't forget my units. I said cows.
So no points will be awarded this round. November, it looks like it's your turn. Which category would you like?
Integral for 300.
Okay. And the question is, what is the volume of the region bounded by y equals 4x and y equals x squared revolved around the line y equals negative 2?
That was easy.
Is it 562.973?
Wow, that was fast, and your answer is correct. Would you care to explain how you got that?
Not really.
Allow me to explain it. First, you graph the functions and you find where they intersect at point A and point B. And second, using the washer method, you find the radius of the outer function and the radius of the inner. And then you write the formula down of the volume, and then you plug in the formulas of R in and R out, and you get volume equals 562.973.
She cheated! How else would you be able to do that without using a calculator or writing anything down?
Jealous much? Surprised you couldn't solve that. You're a kid genius and all.
Okay, let's move on. November, I believe you get the next pick.
Whoopee! I'll take limits for 400.
Limits for 400 it is. What is the limit of x squared plus 5x plus 4 all over x squared plus 3x minus 4 as x approaches negative 4?
That was easy.
Is it 3 over 5?
Yes, that is correct.
First, factor the top and bottom equations. You should get x plus 1 times x plus 4 on top and x minus 1 times x plus 4 on the bottom. You can cross out the x plus 4 on the top and bottom to reduce it down to x plus 1 over x minus 1. Next, plug in negative 4 and simplify the fraction to 3/5.
We clearly see that the answer is
That
3
you
over
cheated.
5.
What? That's ridiculous! The only thing you wrote down on your paper is a picture of me getting hit by a truck.
That is always the correct answer.
As my co-host was saying, the correct answer is negative 3 over negative 5, which simplifies to 3 over 5 or 0.6.
Megan, you're up.
Okay, I'll take derivatives for 100, please.
Okay. What is the derivative of x to the third plus 6x squared minus 8x plus 45?
3x squared plus 12x minus 8.
Looks like we have a tie. You two will split the points and we'll choose the next category randomly for you.
Oh, okay. So the question is, the second derivative of 2 sine x squared plus 4x.
That was easy.
Negative 8x sine x, x squared plus 4 cosine x squared.
Correct. Which category would you like?
Derivatives for 300, please.
Looks like Megan has found the jackpot question.
The first contestant to correctly answer this question gets 777 points. And it looks like with the time we have left, this will be the final question of the day. Megan, you have accumulated a total of 4,450 points this season, and November trails behind with 3,700. Just close enough to win the game should she answer this question correctly. The stakes are high.
Without further ado, let's go to our final question.
As you might guess from our location, this question has something to do with this baseball field, which is a square with 90 feet in length. A player runs from second base to third base at a rate of 18 feet per second. Question part A. At what rate is the player's distance from the base A changing when his distance from the third base D is 22.5?
Part B. At what rate is the angle alpha increasing when D is 22.5? And finally, part C. What is the rate of the area of the trapezoidal region formed by segments A, B, and C and D changing when D is 22.5 feet?
And now for a short break while our contestants work out the problems.
And we're back. Time to review those answers. Put your pencils down. Remember, if November gets this question correct, she will earn just enough points to catch Megan and win the game.
Fat chance, but I got it all right.
Let's look at Megan's answer first. For part A, you got 10.8 feet per second, which is correct.
Oh, I'm for the juice box and suck it.
And November, negative 10.8? Unfortunately, that is incorrect. We'll go back and check your work later, but for now we'll move on to part B.
The correct answer for part B was 0.128 radians per second, and November said 0.128 radians per second. That's correct. Megan said 7.813 radians per second. Sorry, Megan, that's incorrect.
All three parts of this question are weighted equally, each being worth a total of 3 points. So far, our contestants are tied with 3 points each.
Now for part C. Megan answered negative 1,620 feet squared per second, and November said negative 810 feet squared per second. And the person with the correct answer will win the game. $1,000, a new TI Inspire calculator, and 1 automatic optimizer free from our sponsor, Chua Industries.
And the winner is November! Congratulations, November. You are this year's calculus champion.
Can I go home now?
But the show is rigged. My answers are right. I'm going to Stanford. This fall to be the youngest graduate student in this college's history. Sorry, Megan, but it's time to explain the answers.
Segment A is related to D by the Pythagorean theorem. 90 squared plus 90 minus D squared equals A squared. This can be simplified to 16,200 minus 180D plus D squared equals A squared. Next, take the derivative of both sides with respect to t.
Now, dd over dt is given as negative 18 because it is shrinking, and d equals 22.5. Solve for a and you should get a equals 112.5. Now we can solve for dA over dt and get 10.8 feet per second.
For part B, notice that tangent of alpha equals 90 minus d over 90, or 1 minus d over 90. Differentiate both sides with respect to t and plug in a equals 112.5 from part A and solve for dA over dt. The correct answer is 0.128 radians per second.
For part C, remember that the area of a trapezoid is 1/2 c times b plus d. Notice that in this example, b and c are constants. The distance between these bases don't change. Differentiate both sides and plug in values to solve for dA over dt. The correct answer is 810 feet squared over per second.
She cheated, I'm sure of it. Just look at her. She isn't even in college, and she went to public school.
Yeah, and you're like 12. Can I have my check now? My shift at McDonald's starts in like 15 minutes.
Do you see what I mean?
Sorry, Megan. Maybe next year. Congratulations, November. You are the winner of an automatic optimizer, a T-Inspire calculator,
Just give me the check already.
Okay, you should receive it in the mail within the next week.
Give me the one you're holding.
You can't cash this. This is for display only.
You better give me the money right now. I need to post bail for my mom.
Veux-tu me donner ce chèque immédiatement, sinon je t'éclate le cerveau, espèce d'imbécile réglette. Ah, arrête de crier, c'est comme une bébé, espèce d'emmerdeur. Oh là là, je vais prendre le chèque et tu vas voir, hein.